Hey, so for the last lectures, we learned a lot of Python data types. Like we know what are strings, booleans, what are bytes, lists, sets, dictionaries. We also learned some operations on them. For example, we can add, remove elements to lists and from lists. Like we can also work with sets and tuples, etc. We have also learned how to work with functions. By now we know a lot of things that we can actually write simple programs with them. For today, we will look at algorithms. We will look at different algorithms on lists, especially, for example, sorting and searching algorithms. What is sorting? For example, let's say I have a list of grades. For example, I have this list. Maybe there are some methods in statistics. For example, I want to find the median of the list. What's the median? Where you sort the list and you get what's in the middle. For example, if I sort this list, what will happen? What's the smallest one? This is the smallest one. No. Yeah, okay. This is the smallest one. The next smallest one is 66. Then we have 77. Then we have 80. Then we have 85, I think. Yeah, then we have 90. Yes, 90. Then we have 93. Then we have 95. So this would be a sorted version of our list. And if we want to sort in reverse order, the reverse order would be just reverse of it. For example, this is sorted. If I want to find the minimum element, I will get the first element. If I want to find the maximum grade here, I will get the last element. Because the list is sorted, the maximum element is the last one. If I want to get the median of this grades, median is just what's in the middle. These are in the middle. We need to sum them and divide it by 2. We will get the median. So sorting, if I'm not mistaken, yeah. So sorting is really like important operation in programming. That you do a lot of sorting. For example, you get to a web page, you see some table, you sort that table by name. I don't know, by grade. I don't know, by price. Like sorting has very large range of applications in programming. So let's start with how can I sort an array? Let's say I don't have like any ready algorithms. So okay, let's say I don't have any ready algorithms. I just want to write a function to sort this list. Let's copy and paste it to our, let's copy and paste it here. If I want to sort it, just if you think very in basic terms, if I want to, how did I sort this list? I searched, like with my eyes, I searched for minimum element, and I dragged that minimum element to the beginning. After that one, I searched for next minimum element, and then I drag that minimum element here. Then I search for the next minimum element, the next minimum element, the next minimum element, and at last my list is sorted. Okay, we can also do the same with the with just a few lines of Python program. Let's create lesson maybe 4, 5. Let's say we have this grades. So our first tasks will be here to find minimum element from list. Just any list, doesn't have to be grades list. Let's say we are given a list, but we don't know what's going to be inside this list. We don't know the numbers. I just want to find minimum element inside the list. Can you just suggest some versions? How can I find the minimum element inside this list? Just take into account that this list may grow and may shrink. We don't know the size of the list. We will get just size of list with this len. I just want to find the minimum element inside the list. I can, yeah, sorting, but the idea here, we want to sort this array, but first we need to know how, like, I want to sort this list using the minimum element, okay? I still don't know how I'm going to sort, but I need the minimum element to be able to sort this list, okay? Because I am going to write a sorting algorithm to sort any list. Very basic version of finding minimum or maximum element inside a list is just we just guess, okay? This is called brute force. We try every element and we just want to find what's the minimum here. For starting, I just assume that minimum element is the first element. This is not exact, but I just assume that my minimum element is the first element, okay? Then I will go through each element. For example, let's say I say that my minimum element is 90, okay? Then what will I do? Let's say I'm here. Now this is my minimum element, not minimum element. I'll just assume that this is my minimum element. I will go to the next one. Is this less than 90? Yes. So I update my minimum element because now I see that there is actually something which is less than 90. Then we will continue to the rest. Then I come here and then ask again. Salam, just. Then I came here and again ask the same question. Is this less than the minimum element? Yes. So I update my minimum element. So let's continue to the next element. Is this less than the minimum element? No. So we will continue. Is this less than the minimum element? No. We will continue. Is this less than the minimum element? No. Continue. Is this less than the minimum element? No. Continue. Is this less than the minimum element? No. So when I reach at the end of the array, I know that the minimum element inside the array is 60. If I want to write a code for this, actually, this is pretty simple. I will go through, for example, I will go through what, for each grade inside this grades list, what I'm going to do, I ask the same question. If the current grade, the current element that I am looking at is less than minimum element, okay, then minimum element is that element. So basically, this is what I'm looking for. For each item, I just ask, are you less than minimum element? Are you less than minimum element? If they are actually less than minimum element that I have guessed, so if I want to find the minimum element, what I do, I just walk inside the array and ask the same question. Is this less than minimum? 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 And at the end, I have just minimum element here. If I print this, and then I run this code, the minimum element is 60. Okay, this list can be any list. For example, let's add 50 here. And what will I do? I can run the code again. It will give me 50 because it will walk through this list and find the minimum element. Just to recap, to find the minimum element inside a list, what I do, I assume that the first item inside my list is the minimum element. For example, 90. I just assume that this is the minimum element, and I move to the next one. I ask, is this less than 90? Let's write this again just for Murat, also just for continue. Let's say for starting, I just assume that 90 is minimum element, and I come here. Is this less than 90? Yes, so it's minimum element. Is this less than my current minimum? Yes, so it's minimum element. Is this less than my current minimum? No. 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 Is this less than my current minimum? Yes. Is this less than my current minimum? No. So at the end, I know that my minimum element is 50. So to recap the code, I first create a variable, just assuming that minimum element is first element, and I write a for loop to go through each element inside the array. For each element, I ask, is this less than my minimum? If so, that is my minimum. Just for each iteration, I change my mind. Okay, this is like you see a car, and you say that this is the best car I have ever seen, and when you see the next car, then you say that no, this is the best car I have ever seen. You can also change the car with girl, maybe. Every time you see a new girl, you say that this is the best girl I've ever seen. So you update the best girl here. Okay, this is
it like same psychology, like when you go to the website and you see the like products and you put a filter, like start with the top, start with the like cheapest, go to the most expensive.
This is sorting.
Sorting.
Yeah, we actually we find the minimum to be able to sort an element, to sort a list. For example, we have some prices. For this example, we have some grades for some students. We want to find minimum grade and maximum grade. I don't know, maybe we want to find the median of the grades. So we need to sort this array. We just show this algorithm that we can find minimum and maximum, then we will be able to sort. So this is how we find minimum element. Also, we can do the exact same thing to find the maximum element. Also, finding maximum will not be needed in this today's lesson, but just for the sake of teaching, I know it sounds weird, but yeah. Okay, if I change this sign to the greater sign, it means that I will find maximum element. Okay, just because I named this max, let's name this max. Okay, for example, if I want to find maximum element, what I say that, okay, maximum element is 90. Let's continue searching to see if there is anything greater than the maximum element. We come here, this is not greater than 90, this is not greater than 90, this is greater than 90, let's update. So let's continue, this is not greater, this is not greater, this is not greater than 95, this is not greater than 95, it's not greater than 95, so maximum element here will be 95. This is the same logic, we just change the sign here, greater than sign to less than sign, then we will find the minimum. Of course, variable names doesn't make sense for our program, but for humans, we need to name them correctly so that whoever reads our code will understand that we are trying to find minimum element inside this array. Okay. Okay. Let's just write a function for this. Okay, I will create a function. Let's create find a mean index. Let's say find the mean index. What this function will do? It will get a list. Let's say an array. Okay, I call this array any array. It can be this array. It can be another array. I use the word array and list interchangeably, so they mean the same thing. List and array are the same thing. some programming language they call list array. Okay, I want to write a function. My function name is find the min index. This function should find minimum element inside this array and should return me index of that element. For example, minimum element here is 50. What's the index? 0, 1, 2, 3, 4, 5, 6, 7. It should return me 7 for this case. I might give it another input. It should return me the same like expected result. Okay, I will do the same here. For example, min element equals to array's first element, and I will need to return this element. What will I do? I will go through each element inside this array, and if min element is less than min element, then min element is that element. Okay, it's the same code that we wrote earlier, but we can write, for example, let's result 1, for example, find min index. If I give it grades, for example, it will print me what? Result 1. Let me just collapse it so we don't see what's inside this function. This function just what it does, finds minimum element and we can print it. Since the function returns minimum element, we can actually assign that element to a new variable, then we can print it, okay? It gives me the same result. For example, let's add another list here. So minimum element here will be -1. Okay, the -1. So it works correctly. So, but I want my function to return not the element itself, but index of that element. For that, I just need to create a new variable. This is 0 because we start from 0. I assume that minimum element is at index 0. And whenever I find a index, I will say that index is something. Okay, I will update it. Just bear with me. Okay, using for loop like this, I don't have access to index of this element, okay? Because how Python for loops are built, we don't have access to this index of this element. I just can see the element itself, but I don't know what index this element at. So I can use the just regular for loop with range. We start from 0. Actually, we can also skip 0 here. Let's write len of the array. We start from 0 and we stop at the length of the array. We just go from first element to the last length. So element here will be like index will be 0, 1, 2, 3, 4, 5, 6, 7, whatever. And element will be both. For example, if index is 0, this element will be just 0th element inside array. For example, this will be 0, 1, 2, 3, 4, and etc. Now, whenever I find the minimum element, I update also index. I say that minimum element is this element and minimum index is this index. Okay, this is the same code, but I just changed the form. You can also skip the 0 here because how range function works. You don't have to write 0, but for the sake of clarity, let's write 0 also here. Maybe we can also write size just to be more clear, like we go from 0 to the size of the array. Okay, it is not necessary to extract it to a new variable, but just let's do it. Sizə həmin linkə girsə, prosta bura mənə invitation gəlməlidir, mən də accept eləməliyəm.
aklıma girmiş ki burada değil, siz o biri Zoom'dasınız, o biri meeting'dasınız.
Oradan.
Böyle olur.
Another meeting in progress.
And actually write in like this comment here. Finds minimum element inside the array and returns index of it. Okay, it's just comment for anyone who reads our code to see.
Is functions
Function finds minimum element inside the array, inside given array, that doesn't matter. Okay. Okay, so we wrote a function and it works. Let's try. So the index is 4 here. What's minimum? Like 0, 1, 2, 3, 4. So index is 4. We need index. And let's see why we need the index. Let's return to our function. Let's say I want to sort this list. For example, I have this list and I want to sort this list. What will I do? I need 2 pointers. For pointers, I mean, like let's create an I. Let's call this I. And let's call this J. Okay, just I don't know what to name this. Just let's call them I and J. Whatever I do, I will write this kind of code. For example, let's say I wrote a for loop and I am iterating over this list. I have 2 for loops. First for loop is called I, like index is called I, and second for loop starts one later from this one. Like second for loop won't start here, but it starts from here. Okay. And what will we do here? I will always stay here. For example, for now it will stay here, and I will ask J, hey J, can you go to till the end of the array and find me the minimum element? Okay, and J starts his journey, and J assumes that this is the minimum element, as we know our minimum finding algorithm. Okay, J assumes that this is minimum. Is this minimum? Yes. Okay, this is my new minimum. Is this minimum? Is this minimum? Is this minimum? So the minimum element here is this one. Okay, this 60. So what I and J does here, I tells J that, okay, let's give me that 60, whatever you found there, whatever the minimum element is, just give it to me and I will change my place with it. So I and J change their places. I becomes 60 and J becomes 90. And they do the same all over again, but starting from here. Okay, first they started from here. Now they start from here because they assume that whatever left on the left side of us is already sorted. So let's start again. I tells J, hey J, can you go and find the minimum element and give me whatever it is? J starts searching and finds out that the 66 is actually a minimum element, and I and J change their places. So our element at I's index is now changed to 66, and J's index element is 80. Now they continue doing the same thing, and they continue like this. And again, I asked J, hey J, go find me the minimum element. So what's the minimum element here? 77. So they find the 77 and 90 comes here, and they start again the same process. Hey J, go find me the minimum element, and J finds that minimum element is 80. They change their places. They continue for the rest of the array. And what's the minimum element here? Actually, there isn't any minimum element than this 85. So No, there is actually, no, did we change it? Just, sorry. 80, okay, this needs to be 80 and this needs to be 95. I forgot to change it. Okay, and then they continue doing the same thing, but now it turns out there isn't something less than this 85 on the right side of the array, so they continue their journey. And actually this 90 here also is less than whatever on the right side, so they continue their journey. And when they reach to the end of the array, what's the minimum? You see that they're not in their right place. So 93 is less than 95, so they change their places. So when they reach at the end of the array and at the end of this list, and they realize that the array is actually sorted. So this is what happens when we sort a list.
Question. In that case, that you were saying that I was in a minimum number, and the J was searching for the minimum number, but it couldn't find it.
If it couldn't find, it means
But
that
it-
I is actually minimum number.
But it found the minimum number, like, because it means that J sees what I says.
Yes, yes.
Oh, then it means J checks everything.
Yes, I actually says that find the minimum element, like find any element that is less than me, like minimum element that's less than me. I think this is the correct version. If it can't find anything less than I, it means that I is actually the minimum here.
Okay.
So I hope the idea is clear. We can write a function called just sort list. We will also use our function that we already wrote. Our function is find min index. Let's also, before writing sorting function, let's change this function a bit. So I want to call this function, with a starting point. For example, I don't want to start from 0. I want to start from any point. For example, did you see that when we search for minimum, for example, I might start actually searching here, not from the 0, but I might start searching my minimum element from this point. So I need a starting point here. Let's add another parameter to our array. Let's call this start index. And okay.
What's the main function of array?
What?
What's the main function of array?
Array is just a list that we pass to this function. For example, let's say I call this function by using curly braces. I pass it a list. I pass it a list. Now this list becomes this array. Okay, it is as if you created a variable called an array and you assign the list to it. Okay, this is how function parameters work. Whenever I call this function, I pass a value, and this value becomes this element, this variable. Okay, so I give it another parameter, for example, start index. So whenever I call this function, for example, I can give it, for example, I can say it start from 0. I can say it start from 1, start from 0, start from 4, I don't know, start from 2. Start from 2 means that 0, 1, 2. Start from here and find the minimum element. Minimum element here is what? -1. For example, let's say if I start searching from the first element, let's say if I start searching from 0, minimum element is -2. But if I start searching from 2, for example, 0, 1, 2, I start from searching here, minimum element is -1. Okay, you get the idea. So this is what our start index will do. For example, let's actually not remove it. Start index, instead of starting from 0, I will start from start index. Okay, so basically this is it. Instead of starting 0, I start from start index, which is just whatever our user will pass us. Whoever calls this find min index function, they should also specify where should I start looking from. Should I start from the zeros point? Like, should I start from the first element? Should I start from the, I don't know, fourth element? So let's actually test it just manually. Printing the result. If I start from the 0, if I start searching from the zeros element, my minimum element should be -2. Great. What's wrong here? Anyone can notice? Array start index, start index, start index. I start. Oh, maybe I do something. Okay, it gives me the index, right? Minimum element is what? 0, 1. Index is because we return index, not the element itself, but we return the index. You can also, let's just try just returning element itself, just for clarity. So my element is -2 at index 1, okay? If I start searching from second element, 0, 1, 2, if I start from the second element, then my result should be -1, which is at fifth index. Okay. So is the idea clear and how it works? Just instead of starting from the first element, I start from whatever they pass me to.
When do you use side?
What?
Side. You cannot use it.
Size?
Yes, side.
Why?
Well, it's purposes.
Size is just a variable that I call size. It's just length of the array. What's the length of the array? For example, 1, 2, 3, 4, 5, 6. Whenever they give me another array, I will get the length of that array. Is this clear or? Okay, so my find min index function actually works. So we see that it doesn't have a problem. It looks like it doesn't have a problem. Let's hope it doesn't. Okay, I will just collapse this function not to be distracted. We will write another function which is called sort list. Okay, it will get an array. Okay, this is called a sort list. Whenever I give it, for example, if I give it this list, for example, if I give it this list, it should be print me the, let's call this sorted list. Okay, if I call this sort list function and will give, if I give it a list, it should return me the sorted version of this list. And by sorting, we mean, what did we do? While sorting, we found the minimum element and we moved to the first, find minimum, move it to the first, find minimum, move to the first, find minimum, move it to the first, okay? So if I want to write my sort list function, what will I do? I will, let's create another variable, which is called size. It's just length of an array. Whatever array was given to us, it's just length. Okay, what will I do? You remember I and J, where they started? I started here and J started later than I. Just not with I, but started later than I. Just one later than I. I'll write a for loop for I in range 0 and size, okay? I start from the first element and J should start later than I. And I write for in range I shouldn't start at I, but I should start at I plus 1, and I should go till the end. Okay, then if I print I and j, let's see what it prints us. We're just printing I and j. Whenever I is at 0, j starts from 1 and goes till end. Whenever I is at 1, j starts from 2 and goes till end. You get the idea, right? Whenever I starts from some point, j j starts later than I. So what did we do here? Whatever j did, j just tried to find the minimum element from here. Like starting from j, we try to find the minimum element. Just let's call min element. Let's call min index. And did we remove it? Min index. I will call my function which is called find min index, and I will give it the list, and I will also give it the starting point. It shouldn't start from the beginning. Okay, it shouldn't start from the beginning. Search from the beginning. It should start from j and should search to the right. That's why I give it j. Just start from here and search to the right. Okay. Whenever I find this list, I will change their places. For example, array i's element should be array at min index, and array min index element should be array i's element. You remember when we change their place, right? For example, let's say I have a let's say I have here like I don't know, 43, for example. If this is here, for example, we found that 43 is the minimum index here, okay? 43's index is minimum index. I need to swap this I and j. It means element at i's index should be 43, but element at j's index should be 60. I mean, 60. I need to swap them. So this will be 33 and this will be 60. This is what we are doing here. And these 2 lines of code is not correct. Can you say why? Yes, why? So, can you say why they are equal?
You mean there are 2 lines, A equals to B and B equals to A.
Yes. Just imagine like you have 2 bottles. Like you want to, for example, you have 2 bottles. One is Fanta and another is cola.
Yeah.
You want to swap them. I want to have cola in Fanta's bottle and the Fanta in cola's bottle. Well, what I need just third bottle, right? I can't just swap them. If I don't use the third bottle, I will have to just drop all of the cola to the ground, maybe. Then I will lose cola. Okay, I need third bottle. Third bottle, we can call it, I don't know, temp, which just means temporary. I can assign it to array I. I just remember it. Okay, I remember that this was the third bottle. Then instead of using array I here, I will use temp. This is actually a swapping algorithm. Just to swap waters into bottles, you need the third bottle. Actually, this will work because this should work. I hope this will work. We find the minimum element starting from j's point, and we swap them. Then again, for example, when I is, let's say I is 2. For example, let's say I is 2. Then j will be what? 2 plus 1, 3. J will be here. and then it will start searching from minimum, and whenever it finds minimum, they will swap their places. Let's try and see if this works. I don't know what this means. Yeah, we need to return the list, okay? Return array itself. I change it in place, like I change the array. I don't create a new array, I just change the array in place and return. I still don't get what's happening here. Sort list, what's happening? I call a function, this, I give it a list. I need to return the sorted list. Okay, what happened here? This is really messed up. This sorted in backwards. I think the problem is min function. When element is less than minimum element is that element. What's wrong here? So it's correct, right? But in backwards. 60, 66, 77, 88. Yeah, but why? Like we need to reverse it. Yeah, but it should do it without needing to reverse. But let's just try to debug it why it doesn't work. Whenever we find the minimum element, we swap it with the current element, okay? Whenever, like, I start from here, whenever I find the minimum, but it shouldn't find the minimum here. Like, let's see our minimum element. We have minimum element, which is at start point. We have maximum element. No, yeah, we don't need actually this second loop, okay? We don't need second loop. We need just, let's call this J, which is equal to I plus 1. Yeah, we don't need the second loop. It will be like this, okay? We will start finding the, because this is actually the second loop where it like goes and finds the minimum element. We don't need second loop here, we just need one. Yeah, list index is out of range. Where array start index? Can you guess why list index is out of range? Because like, let's say 0, 1, 2, 3, 4, 5, 6, 7. Whenever I is 7, what is J? J is 8, but we don't have 8th element. Okay, that's why let's go till size -1. Not till size, but size -1. In this way, I won't be 8, I won't be 7, I will stop at 6. Okay. And we just have one little error, which is 60 went to the last position for some reason. J is I plus 1, we go find J. Okay, well, let's actually scram, where is my lesson 3? Let's get this. Okay, let's give it the list. Let's try to sort it again. 60, but yeah, whenever it works correctly when we don't have minimum at the last, minimum at the first. Let's move it here, to see if this works. Now 60 is here. Definitely something is wrong. Everything I think is correct except for the 60. 60 just somehow replaced. Maybe we need to just see what's the mistake here. We start from the start index. For example, start index is I plus 1. We don't, whenever we find minimum element, which is less than Okay. Let's do it like this, okay? Instead of passing J, let's do it like this. I pass I here, not I here.
I equals Q minus one.
Yes, yes. But whenever we start searching, we start from I plus one. Okay, let's try this. Yeah, this actually works. I think the error was because we didn't include I itself in the when we are searching, because we need to also include the I itself. I can be minimum. Okay, so it's the same logic here. Okay, J here is this one. We can also call this J. Let's call it. But again, J is this one. Okay, J is start from this. And like I don't expect you to be able to write a sorting algorithm from scratch, because like Python has already a sorting algorithm. Like it has a utility function which is called sort. It will sort the function for you, but I just want you to understand how a algorithm might work. This is actually one of the dumbest sorting algorithms in the world, because this is not really fast. This is slow, and this is good for just for teaching purposes. Okay. Okay. Is this idea, like overall the idea of sorting, clear for you? Also this algorithm. Okay. Let's also write here some commands. This function and this function sorts an array, maybe a list, sorts a list in place and returns it. Let's also call it text. Okay. What I mean by in place, that there are some sorting algorithms that are not in place. They don't change the original array. They don't mutate it. They create a new array and they work on it. And it's bad because it's good because like they don't modify original array, but it's bad because they create a new array. For example, let's say I have a users list with millions of users. If they create a copy of it, like they like take up additional space, right? But if they just modify the array in place, it means they save some spaces. And in some platforms, actually saving space is important. For example, let's say you're programmer and you're working on a IoT device. Do you mean what is IoT? There is a term in internet called IoT. It means Internet of Things. For example, nowadays everything is connected to internet. For example, even a camera, for example. But camera, if you write a program for camera, it has very small memory. You have to use it wisely. For example, maybe GoPro, I don't know, any camera inside a room. Just it's a small device and it has small computation power, and it also has small memory. For example, I have a large device and it has a lot of memory. I don't have to think about just copying an array. I don't know, copying a list. For example, this number, let's say it takes let's actually use it. Do you remember the function we used last lecture? I think it was used. I don't remember the print sys size. Was it size or maybe it was OS? I think last lecture when we used I think there was a thing called how many bytes a string take up. How many bytes string take in Python. Last lecture we used in Code Forces, no Code Forces, in Code Wars. Yeah, get size of import sys get size. For example, get size of, let's say I have just this number. Let's see how many space this number takes up. This takes up 28 bytes for some reason. If I see the whole list, for example, let's see how many bytes this list takes in memory. This takes 120 bytes. Let's say you have limited memory and you want to copy this list. This might take a lot of space. And usually when you write program, you just don't, sometimes you don't only deal with numbers, you deal with, I don't know, a lot of data, strings, booleans. If you have a list of students, probably you have some, what you have, yeah, probably you have some, I don't know, their names, surnames, grades, are they married or not, etc. Okay, we can actually modify this function a bit to be able to sort, for example, sort list of dictionaries. For example, let's say I have a list. Let's call this students. Let's collapse them so that they don't ignore us, like they don't distract us. Let's say I have a list. Inside the list, I have some dictionaries. This dictionary, I have a student named, we have Murat. How old are you? 18?
Yeah.
Okay. Then we need this. So we have one dictionary. We have then Chana. How old are you? 17. Then we have, what was your name? Rasul. Age 19. Then we have Maksud, I think. And Maksud. How old? 19. Okay. So we have this list of students. Yeah, actually they look like they're sorted, but let's a little bit change their places. So we have here, yeah. If I want to sort them, what happened here? Students, we have this one. What's the error here? Was not closed. It is closed actually. Why it says the bracket is not closed, but it is closed. Yeah, but because of this, okay. I forgot the comma. Okay, if I want to sort this list, what I will do, I will give student here. I want them sorted by age. I cannot sort by name. Maybe I can, yes, because of the letters. But if I, yeah, let's say if I want to sort by age, there isn't any way. Let's see how our function compares elements. Our function compares elements directly. For example, it will compare this element, for example, this element to another element, okay? And we cannot compare the whole dictionary. We need to compare just, for example, these numbers or these names. And let's, how can we do this? We can do it like this. For example, let's call name, element name, okay? For example, let's say I want to compare them by age. Instead of comparing the whole object, like whole dictionary, I get age from dictionary and I compare them. If I, okay, what, I didn't print the list. No, so we have Canan, and then we have Murat, then we have Maksud, then we have Rasul. Okay. Rasul's and Maksud's place doesn't really matter because they have the same age, but now we have the sorted list. Okay. Let's see actually what happens if we sort them by name. Then we have first Canan, then we have Maksud, then we have Murat, then we have Rasul because of the letters. You can actually try, let's say, can actually try comparing some numbers. If I compare A with B, what is A is actually less than B. Can you guess why? Because of the numbers.
SQL.
Yes, because of this number. A means, for example, I don't know, 97, B is 98. That's why. And using this logic, actually, and this is how Python compares these names. For example, it says that we have Murat and we have Rasul. So it will compare the first letters. If the first letters are same, it will compare the second letters. As far as I know. Let's do. We have Maksud and we have Murat because A is less than U, then Maksud comes first. But they have the same first letter. That's how it will be compared. Okay. If I want to, usually we don't write our own sorting functions every day, or I don't know. Maybe it will be the last time that we write something like this, because Python has a built-in function called sort, and it is way more faster than our algorithm. It is really fast and efficient. So if I want to sort my list, what will I do? I will call students. This is just a list and sort. It will do all this comparing stuff, I don't know, and changing stuff, and it will sort my array in place as far as I know. Yeah, it says that cannot compare dictionaries as always. We can give it a parameter called key, and not here. Here, can give it key. For example, I say that compare them by name. 3 is not column. What's happening? Yeah, I think this will be a little bit different. Let's I know this looks weird, but positional arguments when one was given. Okay, this is actually how I know it is a little bit weird to give this function. You by giving this compare function to sort function, you just say that I want my elements compared by their name key. There is also another function which is called sorted. This is not sort, but this is sorted. For example, but sorted will not change the array in place. Let's see. This function is like this: sorted. I give it students, and I give the key will be name. We can, if I use sorted function, we can use it like this. History is not object. Actually, I'm wrong because it's. Let's see how it works. Sorted function. Just to be clear, let's go to Python documentation. I go to python.org and I can go to the documentation. I can go to docs and Python docs. Let's go to Python docs, and I want to search for what? Library reference. Then let's go to sorted. Let's search for sorted. Where is this?